Hello, ladies and gentlemen. This is Melike Yildirim from third class of architecture, and today I want to present about frame structures. They are usually a combination of beams, slabs, and columns, and they resist lateral and gravity loads. They overcome large moments which are developing due to the applied loading. Timber framed or half timber houses were already common in medieval Europe. They were filled in with wattle and daub or brick. The modern lightweight wood frame structure house was invented in Chicago. We have an example here on the left side from 1833. The true skeletal construction on a large scale was firstly achieved in Chicago also by William Le Baron Genet in the Home Insurance Company building in the 1880s. And in the 20th century, reinforced concrete emerged as the steel's main competitor. The French architect Auguste Perret was first to give external expressions to frame building, which was in 1903. Frame structures are made by a skeleton that is able to stand by itself as a rigid structure without depending on floors or walls to resist deformation. The materials which are used are mostly strong in tension and compression, such as wood, steel, and reinforced concrete. And heavy timber frames are supporting thick floors and roof beams and are mostly common in construction in Eastern Asia and Northern Europe from the prehistoric times until the mid of the 19th century. The supplanted by American lightwood frame, which are also called balloon frames, which you can see on the right side in the figure. They are composed of many small and closely spaced members. The post must rest on a level on a waterproof foundation, which is usually out of masonry or concrete. The upper stories, they are laid on cross beams, which are supported on exterior walls by horizontal members, and the interior walls also are additionally supported by beams. Here we have a graph how the lateral and the gravity load is affecting the structure. In A and B, we can see the deformation, in CD the shear force, and in E and F the bending moment. Here we have a figure about the load transfer mechanism. So the slabs are supported by beams, columns, walls, or the ground, which are horizontal, but also the beams, they withstand vertical loads and shear forces and bending moments. And the vertical support is by columns, which are supported by foundation, and they transfer lateral loads, moment, and shear to the footing. Here we can see the component parts and their functions. Heavy timber systems have mostly beams, which are strong enough to allow upper stories and roof projection beyond plane of ground floor posts, and they increase space and weather protection with this. The members are usually exposed on the exterior, but here we have an example of the interior. In China, Korea, and Japan, the spaces between enclosed are enclosed by light screen walls, and in Northern Europe they are partly by thinner bracing members and partly boards, panels, bricks, and earth. The light frame is mostly a sheathed with vertical or horizontal boarding or shingling, which is jointed or overlapping for weather protection, of course, and the sheathing also helps to brace as well as the protect frame. It is not significantly improved because of lags behind other modern techniques. Steel framing can mostly used more simplified than the other ones especially wood, because of its much greater strength. It provides more rigidity with fewer members, and the load-bearing capacity is much higher than other materials. Of course, the steel must be protected from corrosion. So the skeleton is mostly covered by curtain walls or surfaced in concrete or sometimes even painted. We have the reinforced concrete framing, which is also greater in rigidity and continuity of concrete frames, which gives more versatility. The steel, the steel is very tall in structures and is also more economical. An example of reinforced concrete framing is the box frame construction, in which each unit is composed of two walls bearing a slab. The advantages of frame structures are that they're easy in construction, they're easy to teach the labor at the construction site, and they can be constructed fast, and the design is economical. The disadvantages are that we don't have long spans. So when we have greater spans, it can cause lateral deflections. So section active structure systems are systems of rigid solid linear elements in which redirection of forces is done by structural members, section, and their load transferring efficiency. And under this category, we have the frame structures. For example, the portal frames. We have three types here: the 3-hinge, the 2-hinge, and the hingeless one. They are mostly used in single-story buildings and generally two-dimensional, rigid frames based on support columns and traversing beams. They are generally seen in buildings which have wide spans, such as warehouses or barns. The 3-hinged frame, the forces can generally easily resolved here using static. Then the hingeless or 2-hinged frame. The 2-hinged and hingeless or fixed end frames are statically indeterminate structures and conditions, and the static conditions have to be used to calculate the end reactions and moments. Then we have the continuous frames, which are used where vertical bracing is not acceptable, for example, for aesthetical reasons or access reasons, etc. The key advantage here is that we have the opportunity to minimize depths of beams. Then we can ensure stability, less economical than by bracing with this method, because we have a combination of two systems that can provide balanced solution. The pin joint frames. Here we have some different truss systems with pin joint frames. They form truss systems, as already said, that has triangular planar frameworks with straight members. They're mainly used in bridges and roof construction. The structural framework consists of several members, such as angles, channels, pipes, etc. The loads are generally applied at nodal points of the frame. The members are always subjected to axial forces and never to bending moment or shear force. The axial forces may be either compression or tension. Braced frame systems. They are composed of beams and columns that are pin connected with bracing lateral loads, and their resistance to lateral forces are obtained through both horizontal and vertical bracing. The rigid frame system has linear elements such as columns and beams. It is rigid and It is resisting both vertical and lateral loads by bending of beams and columns. Here we have an example of the metropole parasol in Spain, which is the largest timber structure actually in the world. It spans distance of 150 meters in length and 70 meters in width. We have mushroom-shaped timber lattices here, and the frame structure creates shadows. We have a 4-level structure. For example, we have a platform in the basement, we have performance areas, restaurants, public, and a public balcony with panoramic views. The material which is used is microlaminated wood called kerto. Another example is the Todai Temple in Japan, which was built very early, which is a Japanese temple of Buddhism. We have a huge structure built on 40 pillars. The front and 2 sides consist of timber, which are triangular in cross-section. They laid horizontally one over another, giving a corrugated appearance. It is 40-meter high, covered with hip-ridge roof of tiles. The next example is the 88 Wood Street, which is in London. It is a superstructure which rises over 18 floors, and the main frame is reinforced concrete and post-tension slabs. The 6 structures, of course, are located outside of the main board, and it is braced external structure with rigid connections between concrete beams and columns to ensure stability. Another example is the Palestra building, also in London, which is a 12-story office building. The building is divided into masses, like one box on top of another. It's supported by these so-called dancing columns on the ground and on the 7th floor levels. These columns lean over at varying angles in 2 directions, including horizontal forces at the top and bottom of each. Thank you for your attention. Here are my references.